Hey, hi students, friends, good afternoon to all. Let us start our today's session. So in previous session, I think we have solved this question. Dimensions of surface tensions are. And what was the option for this year? Correct answer. Who will tell? What is the correct answer for this question? Right answer. Yesterday, I have shown you how to find its dimension or unit. In chat box, I think students have given the authentication. Okay. Option C, yeah, correct answer. Sunil Bhosle. Authentication is the security process validate the claimed identity of the entity. Sunil Bhosle, what you have typed there? Sunil Bhosle. One minute. What is his roll number? 20A. Sunil Bhosle, are you listening to me? Are you there? Sunil Bhosle. Okay. Those persons who don't respond, I am going to remove them from the session. Okay, many students have given the correct answer. That is option C. So enable waiting room. So let us move toward the next question here. I think we have seen this question also. The dimensions of surface tension is. The dimension of surface tension is. What is the correct answer here? Option D. Option D. Option D. Okay. Surface tension unit is here. The unit of surface tension is Newton per meter, right? So how to find out this? Newton is nothing but it is kg meter, right? Per, this is a meter. Now here, this Newton is nothing but it is force. Force is nothing but it is mass into acceleration. Acceleration. So instead of this and this force per unit length, so that is L. We can write here. So here, this m mass m will be as it is. Acceleration due to gravity, it will have the unit L per t square, right? And this L as it is. Those L will this get cancelled, and you will get the unit as m upon t square, or you can write here m into t to the power minus 2, right? So the option D is the correct answer here. See, many students have given the correct answer. Priyanka, your answer is wrong. You have put the B option there. So let us, I think you have written this formula also for this surface tension or not. is equal to 4 sigma upon D. And this question I think also we have solved. What is the pressure difference between inside and outside of the pressure droplet? And the same answer, that is 4 sigma D. 4 sigma by D is the answer for this. We have solved this one. Next, write down the formula here. Write down the title: surface tension on a hollow bubble. If there is a hollow bubble like this, this is the hollow bubble. Okay, so there will be pressure acting on the surface of the liquid from outside as well as from the inside. Okay, because here is also air. Okay, it is a hollow. So on this bubble, the atmospheric pressure, it will act from both sides, and there are two surfaces to this bubble. This is the outer surface and this is the inner surface. So surface tension is a surface phenomenon, and there are two surfaces. So this surface tension, it will act twice. Okay, दोनदा त्या ठिकाणी act होईल. So because of that, if you see the formula for the liquid droplet and the hollow bubble, you will observe there it has increased by twice. Okay, for the liquid droplet, the formula is P equal to 4 sigma divided by D, and for the hollow bubble, it has multiplied by twice. Okay, because there are two surfaces, inside and outside. So the formula will be P equal to 8 sigma divided by D. Okay, so in this way you can remember this formula. Okay, next next is the surface tension on the liquid Z. Okay, liquid Z वरती act on our surface tension, and this is the derivation part. So here we are going to see the formula directly. So write down the formula P equal to, so this L will get cancelled, and you can write this formula as P equal to 2 sigma by D. Okay, it is half of the surface tension, that pressure that is acting inside the liquid droplet. Liquid droplet च्या आतमध्ये जो pressure होता, it is 4. Okay, then now let us solve the problems here. Write down the problem. A surface tension of water, the surface tension of water in contact with air at 20 degrees Celsius is 0.0725 Newton per meter. The pressure inside a droplet of water is to be 0.02 Newton per centimeter square greater than the atmospheric outside pressure. Okay, means pressure inside the liquid droplet P will be equal to 0.02 Newton per centimeter square. Okay, calculate the diameter of liquid droplet of water. Here we have to find out what is the diameter of the liquid droplet. I will hide this part. Can we solve this problem? First of all, write down the given things. What is given? Surface tension sigma is given. It is 0.0725 Newton per meter. Okay, then pressure inside the liquid droplet also given. P is equal to, how much it is? 0.02 Newton per centimeter square. 0.02 Newton. Now here the unit is centimeter square. We have to convert that to meter square, and we know how to do the conversion of that. 1 meter is equal to 10 to the power 2 centimeter, right? That is 100 centimeter. So 1 meter square will be equal to squaring on both sides. You will get here 10 to the power 4 centimeter square. So take this here on this side. So you will get 1 centimeter square is equal to 10 to the power minus 4 meter square. Okay. So now here we can write 0.02 Newton divided by, now instead of this centimeter square, we are going to put this value, that is 10 to the power minus 4 meter square. Now when it will come in the numerator, here we can write 0.02 into 10 to the power plus 4. Unit will be Newton per meter square. Okay. So this is the value of P. Now use the formula P is equal to 4 sigma upon D. Okay. Take this D on this side and P on here. So D will be equal to 4 sigma divided by P. Now calculate it. Has anyone got the answer? Okay, one student has got. (1.45×10⁻³ or 0.00145). Correct. Many students have got the same answer, means that might be the correct answer. So let me check it. Incorrect. So let us solve this next problem. Find the surface tension in a soap bubble of 40 mm diameter when inside pressure is 2.5 Newton per meter square. Inside pressure is 2.5 Newton per meter square above the atmospheric pressure. Above the atmospheric pressure. Solve this one. Now here it is a soap bubble, means we have to use the formula P equal to 8 sigma upon D. The diameter of soap bubble is given, D is equal to 40 mm. Convert that to meter. Pressure is given as 2.5 Newton per meter square. There is no need to do the conversion. And two students have got the answer, Sanket and that's Sonali Shinde, then Vaibhavi Kamble, Rajanandini Pawar. So all of you have got the correct answer for this. Let me check it. Correct. So now let us see the question here. The question is, surface tension is due to, these are the options. Option A, viscous forces. Okay, option B is the answer given by many students. That is cohesive force. And that option is correct one. Many students have got the same answer here. Option B is the correct answer. Surface tension. Next question. If the surface tension of water-air interface is 0.073 Newton per meter, the gauge pressure inside a raindrop of 1 mm diameter will be. This is a question. Solve this and tell me the correct answer for this. Option B, solved, or it is the answer of previous one. Right, sigma equal to 0.073, then pressure 1 diameter is given, 1 mm diameter. Priyanka already has got the answer, option B, 292 Newton per meter square. Quite simple it is, not necessary to take this much time. So Anjali, Ngapat, then Sonali, Sindhi, then Sanket, all have got the option B. So this might be the correct answer. So let us solve this one. What we have to do first, write down the what it is. Yes, sigma is equal to, it is 0.073 and diameter is equal to 1 mm is equal to, you can write here 10 to the power minus 3 meter. P is equal to 4 sigma by D, that is 4 into 0.073 divided by 10 to the power minus 3. This will go up and do the multiplication and tell me the, let me check the answer. 4 into 0.073 into 10 to the power 3. 292 is the correct answer here, option D. Okay. So many students have got the correct answer. Good. This question was asked in ESE 1999. This is the answer. Next question. What is the pressure inside a soap bubble over the atmospheric pressure if its diameter is 2 centimeter and surface tension is 0.1 Newton per meter? This question was asked in IES 2008. Again, quite simple question. Values are given. Diameter of the droplet is given, soap bubble is given, and the surface tension is given. D and sigma is given. Find out the P. Someone has option C. Who is this? Anjali apart. Then Tejasri. Then Rutuja. They have got the option C. Priyanka, Prajakta. Option C, 40 Newton per centimeter square. Sonali, Suraj. So all of you have got the option C. Now let me do the calculations. 4 into sigma is how much it is? 0.1 divided by diameter is 2 centimeters, that is 2 into 10 to the power minus 2 bracket complete 20. 4 sigma, no, it is a soap bubble, right? So soap bubble formula will be 8 sigma. The answer is 40. Option C is the correct answer here. Good. So many students have solved it, and the answer is C. That is 40 Newton per meter square. Now, our next property, fluid property is capillarity, right? So, can anyone tell the definition? Do anyone remember? Does anyone the definition of capillarity? If anyone want to tell, then you can unmute. Allow participant to unmute themselves. Okay, this option I have selected here. So anyone can unmute and give the definition. You can tell the definition.
Rise or fall of liquid surface in a small tube.
Okay. Let your answer be right or wrong. Don't bother. So you have to show the courage. You have to be bold to tell the answers. Let it be right or wrong. Okay. So then only you will become more competent. Capillarity is nothing but, rightly she has told, it is the rise or fall of the liquid inside a small diameter tube. Okay. When we put such kinds of small diameter tube inside a liquid droplet, okay, vertically. So this phenomenon of rise or fall of liquid inside the small diameter tube, okay, so related to the adjacent surface, so that is called as the capillarity. Okay. Phenomenon of rise or fall of liquid surface in a small tube related to the adjacent general level of the liquid when the tube is held vertically in the tube liquid. So as it is a rise or fall, it is a linear distance, okay, measurement. So it is measured in mm, millimeter, centimeter, okay. Generally that rise or fall is in mm, and after that we do the conversion of that in meter, okay. Directly we cannot use that unit meter here because that much great rise or fall it is not going to be achieved, though the tube is smaller. एक एक मीटर ने त्या ठिकाणी राईज किंवा फॉल नाही होणार, ते खूप लहान असते. त्यासाठी आपल्याला त्याचं मेजरमेंट जे either we have to make it in millimeter or centimeter. So the precise unit will be millimeter to measure the rise or fall of the liquid inside small diameter tube. You can see if the unit is millimeter or centimeter. Its value depends upon the specific weight of the liquid, diameter of the tube, and surface tension of the liquid. Okay, so this statement has been derived from the formula or the equation of the capillarity. So for the capillary rise, where this will happen? In the water, you can observe the capillary rise. Okay, and this angle, included angle, the angle of contact with the liquids, this glass tube and water, generally it is 0 degree Celsius, degree, okay, not Celsius, it is 0 degree. And this is the surface tension. Because of this surface tension phenomenon, you can observe here the upper meniscus, okay, and because of that you can observe here there is a rise inside the liquid droplet, that rise inside the tube. Here in case of capillary rise, the adhesive force between the liquid droplet and this Z, it will be more as compared to the cohesive force of the liquid droplets. Okay, because of that it will rise here. But in case of the capillary fall or capillary depression, what happens there? Cohesive force will be greater than the adhesive force, and you can observe such kind of depression inside the mercury. Okay, that is called as the capillary fall or capillary depression. The value of theta, that is angle, it is 128 degree or sometime 130 degree also it can be taken. Okay, so you can write down this formula. For both formulas are same. Here you can see H, that is capillary rise or capillary depression. H is equal to 4 sigma cos theta upon rho ZD or gamma D. Similarly here also the same formula, 4 sigma cos theta upon rho ZD or gamma D. Right. So these are the formulas. I think you might have written these formulas in your notebook, I suppose. And let us solve one problem here. Which one of the following is the correct statement? The capillary rides on depression in a small diameter tube is. Capillary rides on depression. Here there is a mistake. Okay. Here there should be or. Okay. Instead of on, there should be or. Capillary rise or depression in a small diameter tube is. Now here formula just now we have written there. What is that formula? H is equal to 4 sigma cos theta upon
Rho zero.
4 sigma cos theta upon rho ZD or gamma D. Now from this formula you can see there this value of H, it is dependent upon this sigma, that is surface tension. This value of H, it is dependent upon weight density gamma. Rho is nothing but it is weight density, and it is also dependent upon the diameter of the that glass tube. Okay, so this H is directly proportional to the sigma surface tension, and it is inversely proportional to the specific weight of the fluid and the diameter of the tube. If the diameter is large, then there will be a very small rise. It can be observed, rise or fall it will be observed. And if the specific weight of the fluid is very high or large, then also there will be a very small rise you can observe, rise or fall you can observe. If the surface tension is large, then there will be more rise or depression it can be observed. So here, let us read the options here. Option A, directly proportional to the specific weight of the fluid, whether it is true or false. We have to select the correct answer, whether first one is the correct.
False.
False.
False. Okay. Option B, inversely proportional to the surface tension, whether it is true or false.
False.
Okay.
False.
Option C, inversely proportional to the diameter.
Correct. True. Correct.
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 Right. So the option C is the correct answer here. And last option, let us see, directly proportional to the surface area. So in that formula, we don't observe any surface area. So this is not again true answer. This is a false. So the option C is the correct answer for this particular question. Okay. Now time is about to finish. So those students who have remained to give the presentee, they can give the presentee once again. So I will count it once again. Okay, let us stop here.